Okay, so we learned how to create buses, and the rest of this lab, we are going to discuss some other new topics. You know, you can think of these as programming structures in VHDL. One is called process. So a process is a block of code in VHDL that when you want to sequentially assign values to your, generally speaking, saying variables. So how you define a process? Process has uh, three compartments. The first compartment is the label. So a label is is a meaningful name. Should not be started with special characters, and then which is followed by colon sign. This is the label of your process, and then the keyboard process in VHDL. And with that process, you see this parenthesis. This is called sensitivity list. And then later we'll see what sensitivity list is. So in sensitivity list, you list the inputs of your process that when their values are changing, that process will enact that changes accordingly to the variables inside its block of code. And then after that, you have a begin, and the third compartment is begin and end process. So begin end process, and your then the block of code, your sequential design will be loaded here. So for example, one usage of processes is that if you want, later you will see, when you want to implement if statements in VHDL, you have to use that statement or code it within a process. It has to be, written inside a process. Otherwise, you will run into syntax error. So the other thing that we will study in this lab is called internal signals. So let me give you an idea of internal signals. What are internal signals? So technically, internal signals, you can call them as variables. You saw in the ports that you declare them at the beginning of your project, right? Here, for example, these ports. We can think of these ports as global variable. These are the physical ports. These are something that are accessible from outside. And if you think of it, you see that they are actually will be connected to physical ports on the board. But you also have some other things that are hidden from the outside board. Or, for example, in other programming languages, they are called, local variables. They are sort of similar to the local variables. So how you define signals or local variables in VHDL, they do not go inside the entity compartment. Whatever you declare here is your actual physical ports, but the signals that you can think of them as, hidden variables, or local variables. This is how you define them. You need to use the keyword signal, and then after that, you define your signals, and if you have more than one, you can separate them by comma, and then it's followed by a colon, and then the type of that signals. For example, here these are only a standard logic, which means this int1 and int2 are 1-bit binary variables. And for example, here in the new line, you go and signal, you define temp as a signal, and here its type is different, a standard logic vector, and then with width 4, right? So the other thing that you need to think of, signals, and you compare. If you compare the signals and ports, you see the signals does not have any direction. Here, your ports have direction. They are either input of direction input or output. But here, you should not put any direction here. Okay, so this is how you define signals. And again, you should define them after architecture before begin of your VHDL code. Okay, this is the location that you have to put them. If you put them here, or if you put them here or anywhere else, you will run into syntax error. The only location that is you are allowed to define signals is after architecture before begin. Okay, so and then you can think of again signals as variables. The other thing that you will learn in this slide is conditional statements. So we will review several of them, and the concept is exactly the same as what you have seen in other programming languages like C, C++. All you need to make sure here is to learn how you need to write it. What is the syntax? What is the terminology of data statements in VHDL? So if we start with if statement, so if you see with if statement, this is a standard block code for when you want to implement if statement. You need to first start defining the process. You need to put your if statement within a process. So then you see if, and then you have the equal sign in VHDL is I would say is a logical operation. So here it's not assignment. It says this statement condition 1 equal 1 means that if the value of condition 1 it is checking. If it is 1, then this statement returns a true value. And if it is not equal to 1, it returns a false statement. So technically, if the value of condition is equal to 1, then whatever you put after then will be executed here. Otherwise, it goes to else. So here, the other thing that you need to check, you can have like, if you have more than one condition that you want to check, use else if, right? And make sure that there is no e after s. It is ELSIF, right? And then you read this condition. You read it like what I read it here, okay? And then you can continue, and at the end, before the last statement, you put empty else. I mean just only else, and then you write your statement, your block of code here that you want to execute, and you make sure to end your if statement. End if, end process, and you have a complete if statement. So the case statement is, again, you need to put it within a process. And again, so you use case statements when you want to, based on different, values that your variable can acquire. You want a certain, parts of code get executed. So here, for example, you say when is condition 1, or the value is condition 1, then load a signal to with value, put the output set you say when condition 1 is 0, then load signal 3 to signal 2, and then when condition 1 is value is 1, load signal 4 to signal 2, and so on, right? So this is how you read it. It is also in this note part. It is explained for you here. So for part B of your project, the code is actually given to you. So all you need to do, you need to just, whatever is missing from your template, you just you look at this code, fill in, write it in your Vivado, environment, and then here you need, here you say if f equal, if fe is 1, which means equal, you need to show, you need to set a pattern of bit zeros and ones here, such that on your cathode or on your 7 segment, you should show an E letter. And when if L is equal to 1, you need to remove this part, you need to remove and replace it with zeros and ones. Okay, 8 zeros and ones. And do the same in such a way that shows an L pattern here, and also something that shows a G pattern here. And then for else, you come up with, for example, a arbitrary pattern. If, say if it is, the situation is beyond these positions, then, set this one. So, and then, it is given to you here, and do the lab report based on the guideline that is given to you in the last slide. And if you have any question, don't forget to email us. Thank you.